G1000 system is a revolutionary integrated avionics suite that uses cutting-edge solid-state electronics to eliminate analog and mechanical devices. This new system provides key flight instruments with longer life and increased reliability. The complete G1000 system incorporates flight instrumentation and the aircraft's communications and navigation systems. Flight instruments including airspeed, altitude, vertical speed, artificial horizon, turn coordinator, and HSI are presented on one 10-inch primary flight display, or PFD. A 10-inch multifunction display, or MFD, displays the moving map and engine data. ComNav data is always available on both displays. One of the key benefits of the G1000 system is its modular design. If one component should fail, other components in the system are not affected. By using individual line replaceable units, or LRUs, maintenance is quick and easy, requiring a simple removal and replacement of the affected component. Looking at a diagram of the complete G1000 system, it's easy to see the system is comprised of several LRUs. Let's begin with the most visible LRU, the display. The GDU 1040 units utilize TFT LCD 10.4-inch displays with 1024 by 768 resolution. The cockpit is fitted with two GDU 1040 units, one configured as a PFD, the other configured as the MFD. Both GDUs serve to link and display all functions of the G1000 system during flight. Configuration of the G1000 system is accomplished through the use of the controls on the display. The GIA-63s are the central integrated avionics unit. These units serve as a main communications hub, linking all LRUs with the displays. The GIA-63s contain the GPS receiver, ComNav receivers, and the main system microprocessors. The GMA1347 audio control panel is installed between the PFD and MFD. Navcom digital audio, intercom system, and marker beacon controls are integrated into the unit. Manual display reversion is also controlled by the GMA1347. The GRS-77 Attitude, Heading, and Reference System, or AHRS unit, provides aircraft attitude and flight characteristics information to the G1000 displays and GIA-63s. The unit contains advanced tilt sensors and accelerometers that replace traditional spinning mass gyros. The GMU-44 magnetometer senses local magnetic field vectors. Data is sent to the GRS-77 AHRS unit for processing to determine aircraft magnetic heading. The GDC-74A air data computer compiles information from the pitot static system and various sensors. The air data computer provides pressure altitude, air speed, vertical speed, and outside air temperature information to the G1000 system. The GEA-71 is responsible for receiving and processing signals from engine and airframe sensors. The GEA-71 communicates directly with both GIA-63s. The GTX-33 solid-state Mode S transponder provides Modes A, C, and S functions. Control and operation of the GTX-33 is accomplished through the PFD. As you have seen, the G1000 system is truly an integrated avionics suite. What does this mean to you? Better situational awareness, seamless operation, and increased flight safety. In this section, we'll look at the primary flight instruments as displayed on the G1000 PFD. While the G1000's PFD has numerous functions, this section will only describe the primary instruments. Now, for most pilots, the glass cockpit display of the G1000 is a totally new experience. The 6 basic instruments that have been used for years are replaced by a single PFD. It may take some time to become comfortable with the new look of the instruments, but you should find that they are much easier to fly. Taking a close look at the PFD, you can see that all of the instruments in a traditional 6-pack are represented on a single screen. The airspeed indicator, altitude indicator, and vertical speed indicators are represented as tapes. The attitude indicator is located directly in the middle of the display, with the artificial horizon represented as the background of the entire screen. The slip skid indicator, or ball, is shown just below the attitude indicator roll scale, with the HSI located near the bottom center of the screen. Having described the general layout of the screen, let's take a closer look at each instrument and its operation. The airspeed indicator tape replaces the traditional round gauge and is comprised of three components: the range scale, airspeed pointer, and true airspeed box. The range scale is configured with the same colored markings you would see on a typical round gauge: the flap operating range, normal operating range, caution range, and the warning range. The airspeed pointer points at the current indicated airspeed on the range scale. The indicated airspeed is displayed in a window in the pointer. The true airspeed box is located at the bottom of the airspeed indicator tape. The air data computer automatically calculates the true airspeed. Reference airspeed markers can be set to display the best airspeed for rotation, angle of climb, rate of climb, and glide. These reference markers make it easy to target a specific airspeed. Finally, an airspeed trend vector shows changes in airspeed. The trend vector estimates what the airspeed will be 7 seconds in the future. This trend vector can help to detect and avoid dangerous airspeed trends during approaches and other critical phases of flight. Like airspeed, altitude is shown on a tape display and is comprised of 4 components: the range scale, altitude pointer, selected altitude box, and barometric pressure box. The altitude pointer points at the current altitude on the range scale and displays the current altitude in a window. A pilot selected altitude appears in the selected altitude box at the top of the altimeter tape and is represented by an altitude bug. This pilot selected altitude is not used by the autopilot. The pilot selected barometric pressure setting is displayed in a box at the bottom of the altimeter tape. Just to the right of the altimeter is the vertical speed indicator. Like airspeed and altitude, vertical speed is displayed on a tape. The vertical speed is displayed in a pointer that moves on the tape. In the center of the display is the attitude indicator. The information displayed on the PFD is similar to a standard attitude indicator, except for size. The horizon on the G1000 spans the entire display, vastly improving your ability to maintain straight and level flight or constant rate turns and climbs. The horizon line is visible in the background of the other instruments, so you can even detect deviations while scanning altitude, airspeed, climb rate, and heading. If you inadvertently enter an unusual attitude, red chevrons point toward level flight. The horizontal situation indicator, or HSI, is centered in the lower half of the PFD. In the 360-degree mode, it looks like a standard HSI. The current heading is displayed in a window at the top center of the HSI. A course pointer, course deviation indicator, and lateral deviation scale show the aircraft's position relative to the selected course. The HSI can be configured to display GPS, Nav1, or Nav2 course information. The slip skid indicator is a trapezoid located below the roll scale. The trapezoid moves like a standard ball to indicate slip, skid, or coordinated flight. Rate of turn information is displayed directly on the HSI as a heading trend vector. Index marks depict standard rate and half-standard rate turns. There is one more instrument associated with the PFD, the glide slope. Glide slope information is displayed on the left side of the altimeter tape. A green diamond indicates the glide slope position relative to the aircraft. The message "No GS" replaces the indicator when a glide slope signal is not being received. The glide slope indicator only appears when an ILS frequency is tuned and selected on the HSI. As you can see, the G1000's primary flight instruments are somewhat different than a standard instrument panel. Learning to scan this new arrangement will require a little practice, but when you become comfortable, the G1000's instruments offer many advantages while enhancing safety. Traditionally, when preparing to start your aircraft, you would turn on the master switch, lights as needed, and then start the engine. After the engine was running, only then would you turn on the avionics. This process ensured that voltage transients at startup would not damage the avionics. Well, since the engine instruments are initially displayed on the PFD, it has to be turned on before the engine is started. Don't worry, modern electrical systems and avionics have improved significantly, and the problems with voltage transients have been eliminated. Turn on the master switch. At power up, the PFD displays the engine indication system along the left side and begins the AHRS and air data computer initialization process. The MFD powers on and shows a system self-test screen. A scrolling list along the right-hand side of the MFD shows the terrain and Jeppesen database versions and effective time period. When reviewing the startup and self-test data, it is very important to verify that the Jeppesen database information is current. Database information is stored on a 128 megabyte secure digital card. The SD card is placed into one of the two data card slots on the front of the display, making updates easy. When the system self-test is complete, press the Enter key to acknowledge the information. With the MFD up and running, the engine indication system display moves from the left side of the PFD to the left side of the MFD. On the PFD, you will initially see basic outlines of the various indicators that have red X's over them. As the AHRS, air data, and GPS systems come online, each of these items will drop the red X and show the current information. The G1000 system will align the AHRS while the plane is taxiing, eliminating the need to sit still with the engine running, as with many AHRS systems. There are a few important points from this section to remember. The database versions and effective dates are displayed on the MFD at startup. Make sure that the database versions are current. When you press the Enter key to acknowledge the startup screen, you are verifying that you have read and understand all information on the screen. For more detailed information on items covered in this section, please refer to your pilot's guide. The G1000 system is equipped with the GTX33 Mode S transponder. Transponder information is always displayed in the transponder status bar along the lower right side of the PFD screen. The status bar displays the current squawk code and operating mode, standby, on, or altitude. At startup, the last squawk code entered and standby mode are set by default. During takeoff, the transponder automatically switches to altitude mode for Mode S operation. Control of the transponder is accomplished using the PFD soft keys. Press the XPDR or transponder soft key to display the transponder controls. There are 6 soft key selections available: standby, on, or altitude, VFR, code, and ident. We're going to look at the code key in detail. More information on the other soft key options is provided in your pilot's guide. Press the code soft key. This is where you change the squawk code. The soft keys are now configured for numeric entry. To set a new code, press the soft keys that correspond with the code. If you make a mistake, press the BKSP or backspace soft key and reselect the number. When you've finished, press the back soft key to display the transponder control selections. Press the back key again to exit the transponder controls. While in flight, if you are asked to ident, press the ident soft key. The ident soft key is available on all of the transponder soft key selection sets. As you have seen, operation of the transponder is straightforward and should provide you with little difficulty. As always, it is a good idea to review your pilot's guide for detailed information that may not have been covered in this section. In this section, we'll discuss how to tune the comm radios, transfer standby and active frequencies, and cover basic operation of the audio panel. Tuning the comm radios on the G1000 is straightforward. The comm radio display is located in the upper right-hand corner of both the PFD and MFD. Both comm radios can be tuned from either display unit. Dedicated control knobs for tuning the comm radios are located below the frequency transfer key on the right-hand side of the bezel. Pushing the inner comm knob toggles the blue rectangle tuning cursor between the COM 1 and COM 2 standby frequencies. The tuning cursor dictates which comm radio is selected and will be affected by any changes. Turning the outer comm knob changes the megahertz value of the selected frequency. Turning the inner knob changes the kilohertz value. With the new frequency set, pressing the comm frequency transfer key flip-flops the selected active and standby frequencies. Active comm frequencies are displayed in green, standby frequencies are white. When a frequency is either transmitting or receiving a signal, a TX or RX is displayed next to the frequency. Now let's look at the audio panel. The keys on the audio panel are arranged in three logical groups: communication, navigation, and the intercom system. Each key is labeled with backlit text and has a white annunciator above it, making it easy to quickly distinguish which keys are selected. First, the communication keys. Pressing a COM mic key selects the corresponding COM radio for both transmit and receive. The COM keys select which COM radios are monitored. Pressing the COM 1-2 key activates the split COM function. In split COM mode, the COM 1 radio is assigned to the pilot, COM 2 to the co-pilot. This allows both the pilot and co-pilot to transmit and receive on separate radios at the same time. While in split COM mode, the pilot can monitor any selected COM or nav radios. The nav keys are straightforward. Depending on how the aircraft is equipped, pressing the DME, ADF, AUX, NAV1, or NAV2 key selects that nav radio as an audio source. It's important to note that any or all of the nav keys can be selected at the same time. The intercom system has two keys, pilot and co-pilot. These keys are used to select one of four isolation modes: pilot, co-pilot, crew, or all. All mode is active when no intercom key is selected. While in all mode, the pilot, co-pilot, and all passengers are included on the same channel. Pressing the pilot key isolates the pilot from the co-pilot and passengers. Pressing the co-pilot key isolates the co-pilot from the pilot and the passengers. Pressing both the pilot and co-pilot keys selects crew mode. Crew mode isolates the pilot and co-pilot from the passengers. Intercom volume is adjusted using the volume squelch knobs. The inner knob adjusts the pilot's volume. The outer knob adjusts co-pilot and passenger volume. Pressing the manual squelch key allows you to override the automatic COM and nav volume setting or squelch level. Pushing the inner volume squelch knob toggles the setting control between volume and squelch. When volume is lit, the COM nav volume can be adjusted using the inner knob. When squelch is lit, the squelch level can be adjusted using the inner knob. A unique feature of the Garmin GMA1347 audio panel is audio recording and playback capability. The digital recorder can store up to 2.5 minutes of communications in separate memory blocks. To hear the most recent communication, press the play key. Pressing play repeatedly moves backward through the recorded memory blocks. Pressing the marker mute key stops playback and returns the audio panel to normal operation. Any new communication stops playback and is automatically recorded. The GMA1347 audio panel includes a marker beacon receiver that is always on. Marker beacon sensitivity and muting controls are located in the center of the audio panel. Press the marker mute button to monitor the marker beacon over your headset. When marker beacon audio is received, pressing marker mute again mutes the sound. Press the high sensitivity key to increase marker beacon sensitivity. Marker beacon indicator lights display on the PFD next to the altitude tape. The indicator lights cannot be turned off. Finally, the audio panel includes the display backup mode button. In the event of a display failure, pressing the red button reverts the remaining display to show the PFD with engine parameters on the left side. In backup mode, the most critical information is still available to the pilot. More details of the reversionary mode are covered in the section on emergency procedures. During this section, we covered the basics of the audio panel. You should know how to select a comm radio, choose the correct intercom isolation mode, adjust the volume, and playback recorded communications. For more information on the audio panel keys and functions, please refer to your pilot's guide. The G1000 system utilizes Garmin's proven GNS 430 and 530 navigation methodology. Regardless of your experience level, basic navigation with the G1000 is straightforward. This section covers en route navigation using the VOR receiver and GPS. We'll also take a look at flying VOR, localizer, ILS, and GPS approaches. Basic operation using the VOR receiver is the same as other avionics. The navigation frequencies are located in the upper left corner of the PFD and MFD displays. The nav frequencies can be tuned or transferred on either display. As the radio is tuned, or a frequency is transferred, information automatically cross-fills to the other display. The blue box, or tuning cursor, highlights the selected standby frequency. When entering a navigation frequency into a standby position, use the outer nav knob to adjust the megahertz value. Use the inner knob to adjust kilohertz value. With the desired frequency entered, press the flip-flop key to place the frequency into active mode. The G1000 system monitors the active navigation frequencies for Morse code identification. When a nav frequency is identified, the system displays the 3- or 4-letter identification next to the frequency. To help reduce pilot workload, you can select and position frequencies into standby from the Jeppesen database. There are 3 ways to access Nav Aid database information. First, turn the outer FMS knob to display the Waypoint section in the MFD. From here, use the inner knob to get the VOR page. Pushing the FMS knob highlights the VOR identification field. Now you can enter the VOR identifier using the FMS knobs. The inner knob selects different alphanumeric characters. The outer knob moves the cursor to the next character space. To accept the new identifier, press the Enter key. Information for the VOR is displayed below the identifier. To load the VOR frequency in the selected standby field, move the cursor to the frequency field using the outer FMS knob and press the Enter key. The second method is selecting a nav aid using the map on the MFD. To pan the map, push in on the zoom range joystick. Using the joystick, highlight a VOR, then press the Enter key to display VOR details. Load the frequency into the selected standby field as we did in the previous example. The final method of locating and tuning a VOR frequency is to use the nearest function. To display the nearest VOR pages, turn the outer FMS knob clockwise until the NRST page group is displayed. turn the inner FMS knob to display the nearest VORs. The nearest VOR page shows the identifier, the VOR and/or vortex types, as well as the bearing and distance. To select a different VOR from the list, push the inner FMS knob, then use the outer FMS knob to highlight the VOR. To load the frequency into the selected standby field, press the frequency soft key, then press the Enter key. When using the nearest function, a dashed white line going from your aircraft to the selected Nav Aid or airport is displayed on the map. You can select an active frequency for navigation by pressing the CDI soft key on the PFD and cycling through the various HSI presentations. For example, when the Nav1 HSI is selected, the Nav1 active frequency turns green. GPS navigation is accomplished by using a direct-to or flight plan. A direct-to is the simplest method of GPS navigation. To display the direct-to window, press the direct-to key on the PFD or MFD. Using the FMS knobs, spell out the identifier. The identifier can be a VOR, NDB, intersection, or an airport. When the identifier is complete, press the Enter key once. The word Activate is now highlighted by a blinking cursor. Press the Enter key again to begin direct navigation to the entered point. Creating a flight plan is the best method to enter a complete cross-country route. This feature allows you to store frequently used routes. This is useful in congested areas where unpublished arrival procedures allow you to depart or arrive at a frequently used airport. To create an active flight plan, press the FPL key on the PFD or MFD. If you have GPS satellite acquisition, your departure airport is listed as the starting point. Use the outer FMS knob to highlight the first empty data field. Using the FMS knobs, spell out the name of the next waypoint. Once the identifier is complete, press the Enter key and continue the same process until you have completed your route. If you are to fly along an airway, use the VOR and intersections to define the route of flight. To save the route for future use, press the Menu key. Select Store Flight Plan and press the Enter key. To deactivate a flight plan, press the FPL key on the PFD or MFD. Press the Menu key. Using the outer FMS knob, select Delete Flight Plan and press the Enter key. To prepare for an approach, press the PA46 key. The option Select Approach is automatically highlighted when no other approaches are loaded or active. Press the Enter key to select an approach. With the approach field highlighted, turn the inner FMS knob to display the approach list. With the approach list displayed, you can use either FMS control knob to highlight the assigned approach, then press Enter. Next, choose between the initial approach fix or vectors. Again, you select the correct option by using either FMS knob and pressing the Enter key. At this time, you can either load or activate the approach. It is important to note that activating the approach bypasses all other waypoints in your route. Don't activate the approach until ATC clears you to the initial approach fix or begins giving you vectors to final. If the approach was loaded, you must press the PA46 or Procedure key to activate the approach. With Activate highlighted, pressing the Enter key activates the approach. Regardless of the approach type, GPS, VOR, NDB, or ILS, you should load it using this method. The moving map and GPS navigation provides helpful situational awareness. When flying a VOR, localizer, or ILS approach, the G1000 automatically places the proper navigation frequency in the Nav1 active position. Next, select the Nav1 HSI presentation. When flying an instrument approach, The G1000 enunciates your arrival at the missed approach point. At this point, the unit suspends navigation to any additional points in the flight plan, such as the missed approach procedure. To fly the published missed approach, follow the published instructions and press the SUSP or suspend soft key. The G1000 now provides guidance to the fix using GPS as well as suggesting appropriate entry methods for getting established in the hold. We covered a lot of information in this section. As I mentioned earlier, basic navigation with the G1000 is straightforward. Instrument approaches require additional steps. Please refer to your pilot's guide for more detailed information. A key feature of the G1000 system is the large moving map shown on the MFD. While the moving map provides excellent situational awareness, the MFD does much more than just display a map. The left side of the display is dedicated to engine instrumentation. The engine indication system window always shows the following engine parameters: manifold pressure, engine RPM, fuel flow, oil pressure, oil temperature, cylinder head temperature, exhaust gas temperature, fuel quantity, and electrical system information. Information for leaning the engine is available on the lean page. To see the lean page, press the engine soft key, then the lean soft key. The lean page retains the display of manifold pressure, engine RPM, fuel quantity, and fuel flow, while graphically displaying exhaust gas temperature and cylinder head temperature for each cylinder. Pressing the Cylinder Select soft key allows you to see the digital temperature readout of individual cylinders. To assist you in the leaning process, you can press the Assist soft key and begin leaning. As a cylinder peaks, its peak is represented as a hollow bar on the EGT bar graph, and a digital readout of the temperature for the peaking cylinder is shown. In addition, the deviation from peak is shown to assist you in accurately leaning the engine. Refer to your airplane flight manual for proper leaning procedures. Pressing the DFLT or default soft key returns you to the main engine page. Detailed fuel and system status is also available by pressing the System soft key. Like the lean page, the system page retains the display of manifold pressure and engine RPM while showing digital readouts of system and fuel calculation information. The rest of the large display is dedicated to MFD functions. The default screen on the MFD is the moving map or navigation map display. However, there are additional pages with a wealth of information to help you complete your flights safely. Let's start by talking about how to find your way through the various screens. Pilots who have used the Garmin 400 and 500 series products will be familiar with the page layout in the G1000. The screens, or pages, are organized into 4 groups: the Map Group, Waypoint Group, Auxiliary Group, and the Nearest Group. The page groups are listed in a box at the bottom right corner of the MFD. The current page group is always highlighted. To switch page groups, turn the outer FMS knob. Each page group contains multiple pages. For example, there are 4 map pages within the map page group, including the main navigation page, a dedicated traffic map, a dedicated weather map, and a dedicated terrain map. You can move through these pages by rotating the inner knob on the FMS control. As you move through the pages, notice that the page group icon shows both how many pages are within the group and the page you are viewing. The map page group starts with the navigation page. This is the primary page for the MFD. The moving map page shows airports, airspaces, nav aids, and land data. It can also be configured to overlay traffic, topography, terrain, and lightning on the same map page. Pressing the Declutter soft key removes details from the map. The declutter level appears next to the Declutter soft key. The navigation map can quickly be configured to overlay additional information by pressing the Map soft key. Once the traffic, topo, terrain, and lightning soft keys appear, any of them may be selected for display. For example, when you select topo, the navigation map is updated to show topographic data in addition to the basic aviation and land data. Multiple overlays can be displayed at one time. For example, by pressing the Terrain soft key, it will be added to the navigation map without losing the topo or basic data. When terrain data is overlaid on the display, the terrain icon appears in the lower right corner of the map. Traffic and lightning data can also be overlaid on the map by following the same steps. All 4 of the overlays are discussed in more detail in other chapters of this training video. Changing the map scale or zoom level is as simple as twisting the joystick. The current map scale is always displayed in the lower right corner of the map page and represents the area covered from the top to the bottom of the map. To pan around the map, push and release the joystick. This displays the map pointer. Using the joystick, you can now move the pointer around the map. Placing the map pointer over a database object displays basic details about the object. For example, panning over an airport shows the basic airport data in a box at the top left side of the map. To see detailed information about the highlighted airport, press the Enter key. Information about airspace, nav aids, and even land data can be viewed at the top of the screen when panning. The map configuration can be customized even more through the Map Setup option. Map Setup functions will rarely need to be changed and are accessible through the Menu key. We won't cover all of the Map Setup options in this video, so please refer to your pilot's guide for details about customizing the map. Other pages in the Map page group include the dedicated pages for traffic, lightning, and terrain. Turn the inner FMS control knob to move through these pages. The next page group in the MFD is the Waypoint page group. Turning the outer FMS knob clockwise 1 click selects the Waypoint page group. This group of pages allows you to look up information about airports, intersections, NDBs, VORs, and user waypoints. Turning the inner FMS knob clockwise moves through dedicated pages for each of these items. To look up a specific airport, use the inner FMS knob to select the airport page. Then push the inner FMS knob to activate the cursor. With the cursor highlighting the airport identifier, turn the inner FMS knob to begin entering the first letter of the airport identifier. Once you have entered the first letter, use the outer knob to move to the next character. Continue entry until the airport identifier is complete. As you enter the airport identifier, you may notice that the G1000 Spell and Find feature displays airports that match the characters you have entered so far. In this way, you may not have to enter every character of the identifier to complete the entry. Press Enter to accept the airport entry and view the airport information. Airport communication and navigation frequencies can be loaded to the integrated radios from this screen. Use the outer FMS control knob to select the desired frequency from the list, then press Enter. The selected frequency loads to the standby position outlined by the blue tuning cursor. In addition, soft keys are shown so you may view departure procedures, standard terminal arrival procedures, and approach procedures for the selected airport if available. For example, to see a complete list of approach procedures, press the Approach soft key. Use the outer FMS knob to highlight the approach name. Then turn the inner FMS knob to show the complete approach list. Auxiliary pages make up the next page group in the MFD. This group of pages contains mostly reference information. While the auxiliary pages are full of valuable information, we will only briefly cover this page group here. The first auxiliary page is the Trip Planning page. This page provides E6B functions for trip planning, fuel planning, density altitude, true airspeed, and wind. The page can be set to either automatic or manual modes using soft keys. The second auxiliary page is a utility page that contains timers, trip statistics, and a scheduler. The pilot can start a generic timer from this page and can also adjust the flight and departure timer settings. The third auxiliary page is the GPS status page. It shows the current status of the GPS receiver. RAIM calculations can also be performed on this page. The fourth auxiliary page is a system setup page. Various configurations and settings can be changed here. The fifth and final auxiliary page is the system status page. The status and version of each installed line replaceable unit, or LRU, is shown here. Database versions and effective dates are also displayed. Refer to your pilot's guide for a complete description of the features available in the auxiliary pages. The final group of pages is the nearest group. They are the last in the list so that you can quickly turn the outer FMS knob clockwise and see the list of nearest airports. You can't twist the knob too far and go past it, so the page is easy to find. The first page of the nearest group lists the nearest 25 airports. As you scroll through the list, a vector shows the distance and bearing to each airport on the map inset. Soft keys allow you to review additional information about the airport and automatically load frequencies to the integrated communication and navigation radios. The remaining pages display nearest intersections, NDBs, VORs, user waypoints, center, flight service stations, weather, and airspace. From the list of nearest VORs, you can quickly load the VOR frequency into the NAV1 or NAV2 receiver using soft keys. Any of the center, flight service, or weather frequencies can also be loaded to the comm radios by selecting the desired frequency from the list. The flight planning page group is unique because it is accessed by pressing a dedicated button labeled FPL. Pressing the Flight Plan button displays the Active Flight Plan page. This page shows a large map and space for you to enter your flight plan. To enter a flight plan, push the FMS knob, then begin entering your starting point normally. Press Enter, then continue entering waypoints until the flight plan is completely entered. Each flight plan is automatically named using the departure and destination entered. However, the automatic name can be changed if desired. To delete a flight plan, press the menu key, then choose the Delete Flight Plan option. You can also save flight plans by selecting Store Flight Plan from the menu. The next flight planning page is the Flight Plan Catalog. It is a list of saved flight plans. On this page, you can create new flight plans or load saved flight plans. To create a new flight plan, press the New soft key. Once the Stored Flight Plan window opens, enter the new flight plan just like you would on the Active Flight Plan page. To load a saved flight plan, press the inner FMS knob and select the flight plan you want to load. Then press the Active soft key to make it your active route. The third and last flight planning page is the Vertical Navigation page. From the VNav page, you can set up a vertical descent or climb profile. Use the FMS control knobs to adjust target altitude and target position as desired. If you would like to be alerted when it is time to start the descent, press Menu, then press Enter to activate VNav messages. Now you have seen an overview of the MFD functions. Review the pilot's guide carefully to fully understand MFD operations. Also, spend some time flying with your instructor to practice operating the system. In the end, you'll find the G1000 MFD is a powerful tool with many useful features. The G1000 PFD is the main location of information most essential to flight, with the exception of the engine instruments. This leaves the PFD largely static, with the exception of 3 items. One feature of the G1000 is the ability to show crew alerting system messages and some detailed diagnostic information about cautions or failures. With TIS, a traffic annunciator appears above the airspeed tape. All other messages appear on the right side of the PFD display. Warning messages appear in red, caution messages in yellow. These messages consolidate and add information that would have traditionally appeared on a separate annunciator panel. When you have a warning message in red, you also see a flashing red and white warning soft key to help grab your attention. Configuration of the PFD is straightforward and much more limited in the number of changes that can be made when compared to the MFD. There are two items that can be configured on the PFD: the map inset at the bottom left of the display and the HSI presentation. Operation of the inset map is done using the soft keys. To turn on the inset map, press the Inset soft key. Soft key options for additional map data are also displayed. These options are topographic shading, terrain, traffic, and lightning detection. The inset map will present itself in either a track up or north up mode, based on the configuration of the MFD map. Like the MFD map, you can zoom in and out and pan the inset map using the Zoom Pan joystick. One difference between the inset map and the MFD map is, even though you can pan and highlight an item, pressing the Enter key does not display the additional detailed data. To hide the inset map, press the Off soft key. The HSI presentation can be displayed in one of two different views: a standard 360-degree HSI or an arc view. To change the view, press the PFD soft key and then select 360 HSI or Arc HSI. Use the back soft key to return to the main soft key selection set. For more detailed information on the PFD, please refer to your pilot's guide. The continuing challenges of aircraft accidents due to controlled flight into terrain has prompted Garmin to equip the G1000 integrated avionics system with a standard terrain awareness system. Operation of the terrain awareness capability is straightforward. The terrain awareness feature is presented on the moving map of the MFD and as an option for display on the PFD inset map. To show the terrain on the MFD, press the Map soft key and then the Terrain soft key option. To disable terrain, simply repeat the process. For a dedicated presentation of the terrain display, turn the inner FMS knob until you reach the Terrain Proximity page. By pressing the View soft key, the Terrain Proximity page can be configured in one of two views: 360 degrees or Arc. To change the zoom scale of the map, twist the joystick on the right side of the bezel. The range can be changed from a maximum of 200 nautical miles to a minimum of 25 nautical miles. The TAWS page and moving map use color-coded red and yellow terrain tiles based upon the aircraft's current altitude. Red indicates terrain is within 100 feet of the aircraft's current altitude. Yellow indicates terrain is within 1,000 feet of the aircraft's current altitude. Black indicates everything else. When using the terrain feature in the G1000, it's important to remember that this data is provided for situational awareness and is not suitable as the sole means of determining your clearance from the ground. This is literally the rocks and dirt, and does not account for trees or other obstructions, which may increase the overall needed clearance by hundreds of feet. The Garmin G1000 provides graphic display of FAA Traffic Information Services, or TIS data. Traffic information is provided through the GTX33 Mode S transponder. TIS provides traffic data from ground radar sites to the cockpit via the Mode S data link. The radars providing the data are the same sites used by air traffic control. and can only display aircraft with Mode A, Mode C, or Mode S transponders. In order to receive TIS, the aircraft must be within approximately 55 miles of an FAA Terminal Mode S radar site. TIS is provided for up to 8 intruder aircraft within 7 nautical miles horizontally, 3,500 feet above and 3,000 feet below your aircraft. Estimated position, altitude, altitude trend, and ground track information is provided for each aircraft. If there is a potential collision hazard, the system provides a traffic advisory with both visual and audible alerts. A traffic advisory occurs when there is a potential collision hazard within 34 seconds. A potential hazard exists if an intruder aircraft comes within 500 feet of your altitude and within a half mile of your course. Now that we have introduced the basics of TIS, we should see how the traffic looks on the G1000. While there is a dedicated traffic display on the MFD, traffic can also be overlaid on any of the moving map displays. The inset map on the PFD and the MFD map can both show traffic information. Let's look closely at the dedicated traffic page on the MFD so we can see the symbols clearly. TIS uses standard TCAS symbology. Aircraft within the coverage volume are displayed as hollow white diamonds. Their relative altitude in hundreds of feet is displayed above the diamond if the aircraft is above your own, and below the diamond if the aircraft is below your own. Plus and minus symbols also indicate whether the aircraft is above or below your altitude. An altitude trend vector shows whether the aircraft is climbing or descending. A ground track vector shows the direction the aircraft is moving in 45-degree increments. When a traffic advisory occurs, the intruder aircraft is displayed as a solid yellow circle, or a half circle if it is beyond the range selected. An audible traffic alert is sounded through the audio panel to alert you to a new traffic advisory. There is additional important information displayed on the traffic page. The traffic mode is shown in the upper left corner of the display. Verify that the system indicates Operate once you are airborne. You can manually switch between Operate and Standby modes using the Mode soft key. Since TIS depends on Mode S transponder data link, verify the transponder mode switches to altitude after takeoff, or manually switch the transponder to altitude mode. The dedicated traffic display will always be in Heading Up mode, which is indicated in the upper right corner of the display. During flight, you will receive both visual and audible alerts when there is a traffic advisory. On the PFD, a visual alert is shown above the airspeed tape, and an audible traffic alert is sounded through the audio panel. Once an alert is received, use the traffic advisory to visually acquire the intruder aircraft and maintain safe separation. When you fly beyond the coverage of a Terminal Mode S radar site, an audible Traffic Unavailable will be sounded through the audio panel. Traffic Information Service is a powerful tool that helps you see and avoid other traffic. To review the operation modes, traffic symbols, and alerts, please refer to your pilot's guide. The G1000 system is capable of interfacing with various third-party sensors to further aid in situational awareness. A standard item is the WX500 Storm Scope. A later upgrade opportunity to add the Garmin GDL69A Next Generation Weather Data Link will further enhance the system's weather avoidance capabilities. The WX500 lightning detection sensor data is displayed on the MFD and PFD as an overlay option on the moving map, as well as on a dedicated page on the MFD. As with terrain, the dedicated page has two views, 360-degree and arc mode, which is selected via a soft key on the bottom of the bezel. The G1000 controls the WX500. Pressing the Clear soft key clears the currently depicted strike data. Pressing the Mode soft key allows you to select between cell and strike modes. One unique feature of the G1000 system is the aging of the lightning strikes. When a new strike is detected, the system displays a large black and yellow outline lightning bolt for 6 seconds. After 6 seconds, a normal lightning bolt will appear for 1 minute. After 1 minute, the lightning bolt switches to a plus symbol for 1 more minute before being removed from the display. This helps you determine the time of the strike and the rate of growth or dissipation of the storm. For detailed information on interpretation and use of the WX500 lightning detection system, refer to your pilot's guide. Use of lightning detection equipment is not meant for storm penetration and should only be used as a tool in your aeronautical decision-making process. In this section, we discuss emergency procedures. Our focus is on general procedures related directly to the G1000 system. Refer to your approved flight manual for complete emergency procedures specific to your aircraft. There are multiple backup systems available to you if you encounter an electrical problem. It is important to learn the procedures specific to your aircraft as described in the approved flight manual. Another common concern is what to do if a display fails. If either the PFD or MFD fails, the G1000 system automatically switches to reversionary or backup mode. You can manually switch to backup mode by pressing the red display backup button on the audio panel. In backup mode, both GDUs are reconfigured to display the PFD symbology along with engine gauges. In the event of a display failure, the remaining display contains all essential information and retains full system control. One important note: if one GDU fails, you may lose the ability to tune the corresponding COM and nav receiver. For example, if the PFD fails, you will not be able to tune COM1 from the MFD. COM1 will remain on the last frequency tuned. In this case, you should use COM2 and NAV2 for the remainder of the flight. You may be wondering what happens if a remote component fails. The system automatically detects a component failure and displays a red X in place of invalid data. This makes it easy for pilots to recognize and react to a component failure. In addition, dual installation of critical components ensures that a backup is available for essential functions. If you detect a failure and a backup is available, simply use the backup component to complete your flight. While failure of the G1000 solid-state AHRS is far less likely than losing a spinning gyro or vacuum pump, we will discuss it anyway. If the AHRS system fails, you will see red X's in place of the attitude, heading, turn rate, and the slip skid display. If this occurs, use the backup attitude indicator to continue the flight. You may be able to reset the AHRS system by pulling and resetting the AHRS circuit breaker. If a reset does not correct the problem, land as soon as possible using the backup attitude indicator. The G1000 AHRS system uses data from a wing-mounted magnetometer. If there is a problem with the magnetometer, a red X replaces the heading. The course pointer indicates straight up and functions like a typical CDI needle. If this occurs, use GPS data and the wet compass for backup heading information. Like the AHRS system, the air data computer is a solid-state design. Complete failure of the air data computer is unlikely. If the air data computer does fail, red X's replace altitude, airspeed, vertical speed, true airspeed, and outside air temperature information. Use the backup airspeed and altitude gauges to continue your flight. Since the G1000 system includes dual COM and nav radios, dealing with the loss of a radio is simple. Use the working radio to complete your flight. In addition, the audio panel has an analog fail-safe mode so that normal operation can continue if there is an audio panel malfunction. In the event of a total system failure, COM1 reverts to 121.5 for emergency communications. Alert enunciations are also displayed on the PFD. Alerts include warnings, cautions, and advisories. Warnings and cautions are displayed in the warning enunciation window next to the vertical speed tape. Warnings appear in red, while a warning enunciator flashes above the alert soft key. Warnings require immediate pilot action. Yellow caution messages are listed below warnings in the same window. They indicate an abnormal condition that may require pilot action. Both warning and caution alerts are accompanied by an audible tone. Advisory alerts are indicated in white and simply provide general information. A flashing advisory annunciator lets you know that a new advisory message is listed in the alert window. Press the Alert soft key to display the message. This has been an overview of G1000 emergency procedures. Study your pilot's guide and your airplane's flight manual for procedures specific to your aircraft. Make sure you fully understand all procedures so that you are prepared for any emergency.